In this last lesson, we are looking at composites. And we know that a composite is a large shape made up of smaller shapes. So you have 3 of these, and we're going to save that fraction one until last. So let's take a look at this one first. This could be, if it weren't in centimeters, it could be a swimming pool. But centimeters are very small, so maybe this is a sticker. It could be an emblem on a shirt. It's a small patch of some sort, maybe. So let's first deal with these little boxes in the corner. What do these little boxes mean? Those are telling me that these are right angles. These are 90-degree angles. These do not factor into my figuring at all. They're just telling me that these are perpendicular lines. So the first thing I want to do is to divide this shape up into smaller shapes. So my eye immediately wants to do this. And that gives me 2 rectangles. It gives me this little baby one right here. That's going to take me forever, so I can clean this up. So here's this little one. Again, if it weren't centimeters, if this were meters, we could say this is a swimming pool. And maybe this is the baby pool, or the shallow end of the swimming pool. And the other end, the larger rectangle, is the deep end. Okay, so that would be, and I erased part of my line. I should have known better. This won't work as well because I drew that line. And remember, that line is imaginary. So technically, that line should be what? Dashed. If I'm drawing it, I'm just using it as a placeholder. And then on the other side of this swimming pool, I have the larger shape. So I have a rectangle, a blue one, and then this white rectangle that is quite a bit larger. All right, here's the thing that we have to visualize. Let's go ahead and finish this picture. Bear with me just a minute. This is how I do composites. There are other ways to do it, but I'm going to go ahead and draw this in, and since I drew it, I'm going to make it be imaginary. It's not really there. I just want to see that rest of the piece there. Okay, so let's put in some dots, some points. I know that this long edge up here is 12. So this edge is 12. And I know that this one is 8. And I need to know the rest of that line. So if this is 12 and this is 8, how could I find that bottom dashed line? Well, I could say 12 minus 8 is 4. So this one is 4 centimeters. Because I can add the 8 and the 4 to get what? 8, 9, 10, 11, 12. Okay. Then let's do the same thing for the vertical side. So we know this is 9, and we know this is 7. So how could I find this part? 9 minus 7 is 2 centimeters here. So that 7 plus 2 would give me 9. All right. And I am going to put the rest of the dots in. This is not easy for most people to follow. Some people do just fine with it, but some don't. All right, so let's take out the lines I drew. I'm going to take out those numbers where I did my figuring. And that one goes here. This is 2 centimeters. And then this one is 4 centimeters. And let's count our sides on this thing. We have 1, 2, 3, 4, 5, 6. This is a hexagon. So I'm looking for the perimeter of an irregular hexagon. So all I can do is add up the sides. Side 1 plus side 2 plus side 3 plus side 4 plus side 5 plus side 6. And it doesn't matter which order because I am building up. But don't forget to add all of the sides, including those 2 that you found. There should be 6 of them. All right, 12 plus 7 is 19, plus 4 is 23, 25, 25 plus 8 is 33, and 33 plus 9 is 42. So 42 centimeters around this hexagon. All right, let's pull this one up. And the first thing I want to do is section it off so that we have different shapes. And I'm going to make that line right here. If I made it, it's imaginary, so let's make it dashed, just so we can tell it's not really there. It's just to help my eye to see what I'm looking for. So we're looking at this blue rectangle. These won't always be 2 rectangles. Sometimes you'll have a rectangle stuck to a circle, but that gets into more advanced stuff. So for right now, I think the majority of them that I've seen are rectangles. So they will work very much like this. I don't think I've ever taken a math test that didn't have this kind of problem on there. So, but there's only one of them. So if you miss it, it's okay. Don't stress about it. So every corner I'm going to put a dot, a point, because that will help me count my sides. So I have 1, 2, 3, 4, 5, 6. This is another hexagon. So I know that I'm just going to add up my sides. But before I can do that, I need to find one of them. It looks like I have 1, 2, 3, 4, 5 numbers. I'm missing this little piece right here. We need to know what that dimension is going to be. So, to do that, I'm looking at things that go the same direction. So, I know that I'm looking at this one compared to this one compared to this one. And let me do that again. I'm looking at all of the ones that are parallel. There's 8, the unknown, and 5. So to get that unknown, I can do 8 subtract 5. So my unknown is going to be 8 minus 5 is 3 centimeters. And that makes sense to me because look what would be right here if I chose to draw it in. A square. So 3 by 3. I won't leave that there though. So that one, the unknown, is 3 centimeters. And we can take out this part and maybe move that up a little. Whoops, maybe not. Don't want to have to start over. So let me take this out and put it right up here. So this is 3 centimeters. So we just need to add up these sides. I like to write them down, but you don't have to. If you're really good at math in your head, I am not. So I write them down and then I count to be sure I have 6 of them. And then I can start adding them up. 8 and 10 is 18, plus 5 is 23, plus 7 is 30, plus 3 is 33, and then 36 centimeters for the perimeter of this composite. And again, that's a hexagon. These are pretty common hexagons because if you put 2 rectangles together, you will get a hexagon. All right, this one. Now don't panic. This one has some fractions in it, but we can do that. The first thing I'm going to do is deal with that. 7.5 as a decimal is 7.5, and that's meters. 1.5 as a decimal is 1.5 meters. So let's figure out what's missing. There's the 7.5. This one is 4. This one is the 1.5. There's a 2. This one on the bottom, we don't know. And we don't know this one. But we do have another hexagon. So we need to know 6 numbers to be able to solve this problem. So if I'm looking at this one, let's get the bottom, the base first. I'm looking at things that run left to right, horizontally. Okay, and this time it's the long one that I don't know. I'm going to have to build up to find that one. So I'm going to take that 7.5 plus that 1.5. In other words, I'm doing this one plus this one equals this one. So this time I'm adding those two together. So 7.5 plus 1.5, you could use a calculator on this one. That's going to be 9. And this is meters. That's what that M means. So add those two together to get 9 meters. And then I'm taking that away so I don't get confused. We know this one to be 9. Okay, to get this one, I'm looking at things that run vertically. And I'm looking for the longest piece. So if I take 4 and 2 and add those together, I'll get this piece. So 4 plus 2 is 6 meters for this side. And now I have 6 numbers. So the perimeter is 7.5 plus 4 plus 1.5 plus 2 plus 9 plus 6. And use your calculator on this addition if you need it. 7.5 plus 4 is going to be 11.5. 12.5, 13. 14, 15 plus 9. 15 plus 9 is 24. Plus 6 is 30. So the perimeter of this thing is 30 meters. And did you notice that I did not section this one off? I should have. Because we're going to need that for what I want to do next. So let me go ahead and section that one. And erase because I drew in that line. Okay, and this time we have a little square, almost a square, not quite a square, sitting right here. Okay, I want to go back on this one. Let's go back to the very first one. And this time I'm going to change my color to red, my pen, and I want to find the area of these units as well. So let's take this first one. I know that this, let me try this rectangle, that's not quite enough, is it? Hold on a second, you'll see what I'm doing. Here we go. This rectangle is a 4 by 7. So the area, remember, area of a rectangle is length times width. The area is 7 by 4. The area of this part is 28 square centimeters. And then let me do the area of the larger part. Look at them in sections. That did not go well, did it? Let's try again. That still did not go well. So let me not do that. The area of this bigger rectangle is 8 by 9. So long side 9, wide side 8. Area is 72 square centimeters. So the area for the whole thing would be 28 plus 72. So the area for the whole thing is 100 square centimeters. So sometimes you have to find the area of a composite. All right, this one. Let's mark off this piece, if it will let me and not make it warped. There we go. So the area for this piece is 8 by 3. That's 24 square units, in this case centimeters. And then the area for this one, you've got length times width. Now be careful, it's not 10. 10 goes all the way from here to here. So you don't want 10, you just want from here to here, which is 7. So 7 by 5. This is one of those type of problems where you have almost too much information and you have to pick out what you need. So the total area here will be 24 plus the other section, which is 35, and that will be 59 square units or square centimeters. And last but not least, we have the area of this one. And this was almost a square. Oops. I want it to be perfectly squared off there. That was almost a square, but not quite. So this is length times width. That is 2 times 1.5. And that's a total of 3 square meters. This could be a small swimming pool for sure. And then on this larger one, you want, be careful, it's not the 9. The 9 goes all the way across. It's just this dimension. So 7.5 by 6. Looks like what we need. Trace it with your finger if that helps you. So 7.5 by 6. And I'm going to have to work that one. If you have a calculator, use it. I should be able to do this in my head, but I just don't do math well in my head. 42 and 43, that's 45. So 45 square meters for the area of that one. And then remember, we have to add the two sections together to get the final area, composite area, which is 48 square meters. So we started off counting boxes, and look where we've ended up. Can you imagine if we had to draw all those little boxes in here? How complicated that would get. You would have to have 45 of them in the big box and 3 in the little box, and it would be a nightmare. So I'm thankful for formulas.